So you're sitting on the launch pad, waiting for launch. Where do you go? I mean, where are you going to land and what are you going to explore? Let's figure that out. Venus, Mars, we're already on Earth, but all these planets are typically warmer in temperature, similar in size, they're smaller, but they have rocky surfaces, which means you can land there. You see, not every planet we can land on. You see, the gas giants, the outer planets, we can't land on those. In fact, they're mostly made of gas. I mean, Jupiter's atmosphere is so incredibly thick that if it had a surface, we would never actually be able to reach it. I mean, traveling through those clouds of gas would create so much pressure and heat and intensity that we wouldn't be able to make it to the center where there might actually be a landable surface. So we're going to consider the outer planets not landable. But don't worry, they do have moons. For example, Jupiter. Jupiter has some pretty magnificent moons that you can actually land on, much like our moon, except they have lots of different features. For example, here we have Io, Europa, we have Callisto, and we have Ganymede. But let's take a special look at one of the moons of Jupiter, and that's Europa. You see, Europa is a planet, or not a planet, it's much like a planet, that's actually a moon of Jupiter. It has an icy surface, and actually on the surface are these geysers. You see, scientists from NASA started exploring and observing Europa, and they started to realize that there was these giant ice geysers shooting out, which meant two things. One, there's water somewhere, and two, there's enough pressure and heat somewhere to shove that water to the surface and cause it to explode into a plume of iciness out into space. And so scientists began to believe that there was an ocean under the surface of Europa. And now scientists at NASA have begun to plan explorations and actual missions to Europa. They plan to drill through the ice and use submersibles to actually explore to see, could there be life at the bottom of Europa? You see, this is also a landable object. So if I'm on my spaceship, maybe I go and visit Europa. So why even go to another planet? I mean, what's the purpose of it? I mean, everybody knows the answer to that question. Aliens! Yeah, aliens, big green guys with big black eyes, and maybe they're underwater and they're living in a coral reef somewhere. I don't know. Maybe they're invaders and they're trying to take over the world and they're going to be out for our certain doom. Probably not. In fact, the life that we're probably going to find on another planet someday is going to be the most simple form of life, a microbe. And it's probably going to look nothing like the complex life of aliens. I mean, in fact, we think of aliens as little green men. We're probably going to be microscopic green worms of some kind or green microbes of some kind. So why even go there to find something so small? Well, the truth is, it comes back to the biggest question is, why are we the only planet with life on it? And why haven't we found life so far? I mean, life is beautiful, but why can't we find it? And the truth is, life is difficult. And so we're going to answer the question, why is life so difficult to find? Why can't we find it? And it really boils down to what makes life possible, or more so, what makes life difficult. You see, here on Earth, we have the correct atmospheric conditions to actually sustain life. You see, we have the sun going into the surface of our atmosphere, and our atmosphere is thick enough, but not so thick that it crushes us. And so because of our atmosphere, we're actually able to trap heat to keep the temperatures warm enough for life to thrive. Not only that, we have the right mixture of gases in our atmosphere. I mean, we have nitrogen and oxygen, and those are two big components that really help life to thrive. For example, you saw me breathing at the beginning of this video. Well, the breath that I was breathing in was actually mostly nitrogen and oxygen. And a lot of other planets don't have that same type of atmosphere. That atmosphere, those gases, that thickness of the atmosphere allows life to thrive. It allows the diversity of life to take over, and it allows us to have things like penguins. It allows us to have things like bumblebees and different flowers and all this diversity of life. In fact, we're the only planet that we know of that actually has this incredible diversity of life, and it has to do with our amazing ecosystems. The different environments around our planet that are able to grow and are able to thrive because of our atmosphere, because of where we're located. Take Venus, for example. Venus is Earth's evil twin. I mean, it even spins the opposite direction. You see, the surface of Venus is actually something to be terrified of. Even though it has an atmosphere similar in the makeup to ours, I mean, it has a troposphere, a stratosphere, a mesosphere. But you see this red line here? This red line here represents the pressure, the atmospheric pressure. And on Earth, it's 14.7 psi, right? That's 14.7 pounds per square inch. But on Venus, it's about 90 times greater. 90 times greater, enough to crush your bones because of that pressure, because the amount of gas inside of Venus's atmosphere. And a lot of that has to do with the fact that it's loaded with volcanoes that are constantly erupting. And not only that, Venus, because of those volcanoes, has a poisonous atmosphere. In fact, ours is mostly nitrogen and oxygen. Venus is mostly carbon dioxide, something that's a poisonous gas to us that would cause us to suffocate and perish. Not only that, the heat on Venus is incredible. It is so incredibly hot on Venus that you could actually melt metal. I'm not joking. If we were to land there, the metal would actually begin to melt and blister. You would have to have special types of alloys to actually get it to survive. To top it off, Venus not only has volcanoes and intense heat and carbon dioxide, it has sulfuric acid clouds that rain acid. I'm not kidding. It literally rains acid on the surface of Venus. Acid so much so that if we were to actually take off a glove and put our hand out, it would instantly begin to burn and corrode. And we would be definitely in a lot of pain, if not dead, in a few mere seconds. So we have to have the right atmospheric conditions. But we also have to be in the right place in the solar system, what's called the Goldilocks or the habitable zone. You see, there's really only two planets that are located in this habitable zone, Earth and Mars. The big difference between Earth and Mars is that Earth has this amazing atmosphere that allows life to thrive, but Mars doesn't. In fact, Mars has an incredibly thin atmosphere that's actually leaking out into space. This is called a hazard. You know, Mars at one point in time may have had the right kind of atmosphere to sustain life, but it no longer does. And that makes life difficult on Mars. Even though it's in the right spot, it doesn't have the right kind of atmosphere. You see, the temperatures on Mars are so extreme. I mean, in the summertime, it's 63 degrees. That's nice. But in the winter, it's negative 220, colder than any temperature ever observed on the planet Earth. It's even colder than anything we've ever seen in Antarctica. In fact, on year-round, the average temperature is negative 81, which this is why life is really difficult on Mars, because it doesn't have that atmosphere like we do to trap that gas, to trap that heat. And so that's one of the things that makes life difficult, the place, the atmosphere. But also the third thing that makes it difficult is it's just difficult to find because space is really big. I mean, take Uranus, for example. Uranus is 2,871,000,000 kilometers from the sun. That is 19.2 astronomical units away. It would take us 8.5 years to travel to Uranus. 8.5 years. I mean, that's a lot of time in space, and that's more time in space than any astronaut has ever spent. Let's say we wanted to travel to the nearest star, Alpha Centauri. Well, to get there, Alpha Centauri is 268,770 astronomical units away. That makes Pluto look like a trip to the door. That's about it. You see, it would take light. I mean, light moves incredibly fast. It would take light 4.25 years just to get there. For us, it would take 100 years, moving at the fastest speed in our SpaceX Starship space rocket. 100 years just to get to Alpha Centauri. So why are we doing this? And what are we doing? Well, the truth is, you're going to hop on that Starship. And I want you to convince people to come with you to a certain planet or a moon that's landable. And you're going to be creating a poster to convince people to go. You see, here are some examples from last year. Here's a student that decided to convince people to go to Titan, a moon of Saturn. Here, this student wanted to have people explore Venus with her. So she made a poster convincing people to explore Venus. And in this poster, you've got to make the bad sound good. You got to make the hazard sound adventurous. And that's going to be difficult to do. But doing that is going to allow people to jump on board with you and say, I want to go. But once you get there, you also got to convince people that it's safe. And that's where you create a shelter. You're going to be creating a shelter that allows people to survive on the surface of this landable planet or moon. Here are two examples from last year. These are models of what they might have looked like. You could see the labels in there and how they labeled different things that would allow them to survive. Well, since we can't be in the classroom, we're not going to make them this way. We're actually going to use Tinkercad to create our models. So in order to get here, we have to understand that we got to complete some tasks. For example, task 1, you got to find a landable object, right? I mean, if I want you to choose a landable object to go and explore and convince people to go, you got to first find it. And that's what task 1 is all about. And that's where we start. You see, task 1, the very first thing you're going to do is to find landable objects. And you can find this task inside of Google Classroom. Once you've found landable objects, you're going to choose 3. Now remember, this whole time you're going to be working with a partner. And you and your partner are going to choose 3, your 3 favorites. And you might say to yourself, well, Mr. Gain, why 3? Well, I'll explain that in just a second. But once you find those 3 and you choose those 3, let's say, for example, you chose Ganymede, a moon of Jupiter. You're going to research the atmosphere, the distance from the sun, the time it takes to travel, the interesting features, the things that like really stand out to you. Like maybe there's a really cool volcano or a mountain range, or like there's this really cool acid lake that you want to go check out. But then you also want to tell people about the hazards, the things that could harm them. And you might still be asking yourself, why 3? Well, because these resources may not have everything you need. And we're not going to be using Google to find these. I mean, you might use Google to place the picture there, but other than that, you're not going to be using Google to find the information that you need. These resources here and inside the task 1 assignment, because there's a couple of good ones in there too, are going to allow you to find this information. You can use Solar System Scope, the NASA Planet site, which is really good and easy to follow, Epic, which I've given you the code and you've got your own account there. And then the last thing is a travel time page. You see NASA's JPL, the Jet Propulsion Laboratory, has actually figured out how long it would take to ride a bike to each planet. Not only just ride a bike, but also fly a rocket. And so that's what you really want to use to help you figure out the time to travel. There's also another really great resource that I just put inside of task 1, and I'm going to continue to add more as they come. And so you still are asking yourself, why 3? Because there might not be enough information on Ganymede, so you need to do another. You see, you want to choose the planet that is going to give you the most information, or maybe sound like the most interesting to go to possibly even find life. And that's really why you're going to pick 3 and then narrow it down to 1. I don't want you to get your heart set on 1 and then realize that there's no information on Ganymede. And so that's why I'm having you choose 3. So this is your task. Good luck today. And I look forward to seeing what incredible information you find and the amazing posters that you're going to create.